So this is section 4. We shall cover t-test. There's 3 types of t-test: one sample t-test, independent t-test, repeated measures t-test. So let's move on. T-test. T-test is used to compare 2 estimated population means, and it allows us to determine the degree to which they overlap. So we can have 2 estimated population mean and the degree where they overlap. So basically what it means, we've got sample 1, estimated sample 1 and sample 2. So the degree in which they overlap is this one. So that's how t-test is used. We want to compare 2 estimated population means. Unlike the z-score, no population parameters are needed to perform a t-test. The t-test allows us to test the differences between the means using an estimate called estimate of the standard error. There are 3 types of t-tests, namely 1 sample t-test, then independent t-test. Under independent t-test, there are 2 types: the one which uses pooled variance and heterogeneity of variance. Then there is the repeated t-test. So degrees of freedom. When using sample data, we have to correct the sampling error by using the degrees of freedom. So degrees of freedom are defined as the number of scores in a sample that are free to vary. So it means we just want to see, like, because we're estimating, so we are just given the degrees of freedom is just given the flexibility of varying. So just know, so normally df is a symbol used to represent degrees of freedom. Characteristics of t-distribution. The t-distribution is a family of distribution with a slightly different distribution for each sample size. So the slightly difference is because of the degrees of freedom. It is flatter and more spread out than the normal distribution. As sample size increases, the t-distribution approaches a normal distribution. We'll start it in the next slide. So we can see that when the degrees of freedom is equals to 1, it's small. It's forming this shape. When the degrees of freedom are increased to 20, you can see it's coming towards the normal distribution. This is 5 for the green one, and 20 is for the blue one. So for the normal distribution, the degrees of freedom are infinite. So you can see. So as the degrees of freedom increase, the t-distribution approximates the normal distribution. So when df degrees of freedom are large, the curve approximates the normal distribution. This is because as n is increased, the estimated standard error will fluctuate as much between samples. Okay, so you see, that is how it is. So degrees of freedom, I think you get the idea of what we're saying. It's just the flexibility that is treating it. So for one sample t-test, we use this formula: standard deviation, mean minus sample mean minus population mean divided by sample standard deviation over square. So this one is more like a sampling distribution of mean we discussed later on. Sampling distribution of means. But now, because we are doing the t-test now, we incorporate the degrees of freedom. So when you are calculating your standard deviation, you use n-1 to incorporate the degrees of freedom. So if you just use n, you are not going to get the correct standard deviation. So make sure you use n-1. So let's use an example to demonstrate this concept. We are asked to determine if a new meditation technique can help reduce the intensity of panic attacks. We measure the severity of panic attacks by asking patients to rate the intensity of attack on a scale from 1 to 20. From years of using this method, it is known that panic attack sufferers give a mean rate of 14. Mean rate of 14. The population mean is 14. We teach the new technique to a group of panic sufferers and ask them to rate their next attack. We collect data. So this, you can see this one symbol. So use alpha equals 0.05 and a two-tailed test. So the two-tailed test is coming from this one. They have already indeed give a hint for you. So this one is, so let's solve it. So now we know that is the one symbol t-test. So our in our t is equals to x power minus mu over s. Okay, let's solve it. So n is equals to 9, your mean, remember, of this symbol. Remember, we add these ones. We add this one to calculate the mean. So you see there are 9 items. So if you add all this one, you get to 114 divided by 9. Then you get your mean. So for you to get your standard deviation, you input your numbers. These are your x, which are in this manner. Then you subtract this one minus your mean, you get these ones like we demonstrated earlier on. Then once you do that, you square these values, then you get these numbers. So once you add them, you get this total. So that is the total we have inputted here, but you remember it's saying 9 minus 1. So you get 5.567. Once you have done that, you proceed. These are just changed. So now your standard error is s over square root of this one, 5.567 divided by square root of 9, get 1.855. Then from there, incorporate your one sample t-test formula, then you get these values. So the degrees of freedom for this particular one sample t-test is n minus 1. So n is the number of items in this sample. So it was 9 minus 1 is equals to 8. So this is the degree of freedom. So now you go to your t-tables. So t-tables, you look for two tails t-test. Then you are looking at 5%, which is your alpha. So the number of degrees of freedom is 8. So you go this one and link it to 0.05. So your critical value is 2.306. So let's type it again. Remember from equation, your alpha is 0.05 and you're given that is a two-tailed test. So you go to your two tails at 0.05, then you link it to 8 degrees of freedom, then you get 2.306. So once you do that, this is just to remind you, state the hypothesis is there, define your significance when it's there, define your critical values. It's this one and this one. So remember, it's a two-tailed t-test. So once you get, you put your two t-test. So these are your critical values. Remember, when it's symmetrical, so you know that when you want to get your 2.2, since the two test, the other one will be minus. So calculate the t-test statistic. We've already done this and you got this one. So your test statistic is less. So maybe your 0 is here. So your minus 0.719 is here. So we accept H0 at alpha and conclude that the new meditation technique can help reduce intensity of panic attack. So let's recap. First, you calculate your symbol. You know that the n is the number of items in the symbol, and to calculate the mean is sum of the items given here divided by the n, the number, then you get this one. Then remember to use this table to reduce errors. So 12, these are the items in the symbol. Then you say x minus mean. So you're saying 12 minus 12.667, then you get this one. 18 minus this one, then you get 5.33. Continue up to this. Then you, once you get this number, you square it. Minus 0.667 squared, you get this one. 5.333 squared, you get this one. Continue the same thing to get these values, then you add them. Once you add them, then it means this value that you get is your summation of x minus mean squared. This one, if you sum this one, you get this one. So that's why we put it here. Then remember n is n minus 1. Then you get your 5.567. Then you continue to solve your standard error. This one. So it will be this one. Then it's incorporated. This one. Then this is a mu you got from previous example. And this is your population which was given 14. Then you will get your test statistics. Then the number of degrees of freedom, n minus 1, your n is 9. Then you get your degrees of freedom as 8. Then you go to your tables. Since the two test is 0.05, then you come at 8 degrees of freedom, df. Then you, when they intersect here, you get your critical values. So it means this one is a positive one. So since the two tier test, the other one will be a negative. So that's why we put these ones. Then we accept. Next one, independent t-test. The first one is the pooled variance. Use the pooled variance as your standard error estimate unless the sample variances are not homogeneous. Due to the fact that there are two independent samples used for this test, it's problematic to approximate the shared standard error by making use of variance of one of the samples only, especially if the sample sizes are different. To avoid this difficulty, we find an average variance of the two samples so as to ensure that the larger sample doesn't overwhelm the smaller. We use a weighted average, referred to as the pooled variance. It's given by the formula on the next slide. So this is the formula: sample 1 and sample 2 with the 2. So this mean of sample 1, mean of sample 2. Then we use this formula like this. So this is for the pooled variance. Then degrees of freedom, you add n sample 1, sample 2 minus 2. That is the formula for the degrees of freedom. Then the other one is independent t-test heterogeneity of variance. If your data doesn't have homogeneity of variance, it is still possible to analyze the data by making few changes to the procedure. There are two changes involved. Don't put the variance, but rather use separate variance estimate formula shown on the next slide. Change and use different formula for the df. Rather use the smaller between. So now let's say you have two different sample sizes. Let's say for sample 1 is 10 and sample 2 is, let's say, 15. It means what you do is this one minus this one, get 13. This one you get 9. So you use the smaller one. So we use the smaller one, 9. That's what they mean. So this is the formula for the heterogeneity of variance. Remember we said don't put the variance, but rather use separate estimates shown on the next slide. So this is the for heterogeneity of variance. So to be S1 like that. So to determine whether to use pooled variance or heterogeneity of variance formula for independent t-tests, we use the following formula. So S1, S1 variance 1 divided by variance 2 of sample 2. If k is less than 4, use pooled variance. If k is greater than 4, use heterogeneity of variance. So now for this one, you should put the bigger one on top so that you don't get a fraction. You put the bigger one on top. Let's say sample 1, S1 is 10 and S2 is 20. If you say 10 over 20, okay, this was 10 over 20, what you get is 1 over 2. But in fact, for this formula to work, you should use the bigger one on top. So it means you're supposed to just interchange them and say 20 over 10. Then you get your 2. So it means if k is less than 4, you use pooled variance. If it's greater than or equal to 4, you get heterogeneity of variance, which is this one. So now, let's look for an example 2. We are asked to investigate whether a new technique for teaching mathematics in dyslexic children is effective. To this end, we use a new teaching method on a class of dyslexic children. We prepare a math test and administer this test to the class we have taught with the new method, as well as another dyslexic class in a nearby school we have been taught with the traditional method. Because the classes have no common factors between them, we can think of them as independent samples. We name the class taught with the traditional method A and the class taught with the new method B. The results are marks out of 100 for each child are presented below. So this is for A, this is for B. So which means for A and for B, we can determine the mean, the S, and several things. So did the new method work? So now, did the new method work? It means they're not saying it's greater or they're not saying it's less than. So it means they are not specifying the direction. It's non-directional. So you use for H1, use this one so that you will get your hypothesis. So let's move on and solve it. So for A, number of items is 14. So these are the numbers. So if we sum them up, you get 377 divided by 9. Then your mean is 26.93. Then your standard deviation. Remember, you always use n minus 1, n minus 1, n minus 1. If you use n only without a minus 1, it means you get a wrong answer. So you repeat so this is 15 minus the mean. So 15 minus 26.93, you get 11.9 something. Then you square it to get this one. So you do it for all this one. Once you do that, you're able to calculate this. So this is the same for B. Then it's 14. If we add up the values of B, the 912 divided by 14, get 65.4. Then you calculate your variance. Then you input these figures. You're supposed to get 289.967. And once you've done that, you know that your hypothesis is mu A is equal to mu B. Then your alternative is mu A is not equal to mu B. So in other words, they're saying traditional method and is not equal to new method. So for the values we've calculated, that is what we have from the previous. You can see this is which I just put them on one page. So now the first step is to determine your K. So you say the bigger standard deviation should be on top. So this one should be on top of this one. So now you want to do that, you get 2.64, which is less than 4. So you use pooled variance. So pooled variance is of this manner. So now this is the formula for pooled variance. So you input your figure. So your sample 1, N1 is 14, sample is this one and this one and this one, like that. So once you input your figure there, you're supposed to get 199.64. So for you to get your t-test now, remember this is your food variance. You've already calculated this part of it. So SP, you've already covered it here. So once you do that, then you input your figures, then you're supposed to get your test statistic like this. So degrees of freedom is 14 plus 14 minus 2, then you get 26. So once we've done that, remember K is less than for food variance. Then you go to the two tables now. The two tables are saying the two-tailed t-test. So you go to two tails 0.05, then you go to 26 degrees of freedom, then you get your 0.056. So because of that, we reject H0, because remember, we have 14 minus 7 here. So it will be like something like minus 7. So for two, it's like this and this. So it's like 2.056. Remember, this is negative. And this is 2.056. So it's always good when you're solving these questions to draw this graph like what I'm doing. It will help you to completely visualize what you're doing. So minus 7 point something is like way ahead of this. So it's somewhere here. So it means we reject, because this is minus. So that's why we are concluding reject H0 and conclude that the children are performing better with the new method. So you see, but remember here, I didn't just remember to specify reject H0 at 5%. At alpha, I can say alpha at alpha is equals to. So remember always to specify your alpha. We are rejecting H0 at alpha is equals to 5% and conclude that the children are performing better with the new method. So always include alpha. If you don't do that, because now if your alpha is equals to 10, it can lead us into accepting it. For example, if your alpha is 10%, it may result. So you must always specify that you are rejecting at alpha is equals to 5%. So the third part is the repeated measures test. Repeated measure test, aka known as related samples t-test, is used to compare means when the samples are not independent, i.e. the same subject are used for both samples. The formula on below is used to call the repeated measures test. The formula below is to solve the repeated sample. That was just a typo error. So repeated sample test, you've got your D, mean of D, and this is your SD and your D, sample number of items that are being tested. So you shall understand it as we solve it. Okay, example 3. We are investigating whether a new medication to combat insomnia is effective. We recruit a number of insomnitics and ask them to record over a 2-month period how many sleepless nights they experience. Once the 2 months elapse, we give the new medication and ask them to do the same for another 2 months. Because we are using the same subjects, this is a repeated measures design. So repeated measures is using the same subjects. We collect the data shown in the table below and need to calculate T to determine if the improvement was statistically significant. The hypotheses are in this one. So we are investigating whether it's less than So sleepless nights for insomniatics on medication treatment, difference variable with difference variable. So now before and after. So before, this is the first one, and after, this is the second one. So the difference, say 30 minus 42 is minus 12. 32 minus 40 is minus 8. So you continue. This is the formula. So when you're doing so this difference, when you say the difference, so you can see that this difference, we take the mean of the difference. We take the mean of this. So it means we add all these values and we divide by the number of items. So there are 1, 2, 3, 4, 5, 6, 7, 8, 8. So the total is minus 35 divided by 8. You can get minus 4.375. So for you to get the standard deviation of the difference, so it means you say the difference minus the mean. So the mean is this one. So minus 12 minus 14. So remember, don't get confused here. So we say minus 12 minus 4.375. It means that 2 negative will become minus is equals to plus, so it becomes 3.75. You understand? So when you solve this one, that's how you get this one. So it's the same for this one. So maybe let's try this one. When you say 1 minus 4.375 becomes a positive. So it becomes 1 plus 4.375. So when you do that, you get this one. So the trick here is to know that minus is equals to positive. The sign will change. So if you do that for all these ones, you are supposed to get these figures. Then after you get these figures, you square them. Then you square them, like minus 7.625 squared is equals to 58.140.625. So when you square them, then you add them. It gets roughly this figure. So when you get that figure, you can input it here. Remember, your n is 8, so n minus 1 is 7. So once you do that, you get 7.6333. So let's recap. First, sometimes in these questions, they can just give you before and after without putting the difference. So it's up to you now to calculate the difference. But for this example, the difference has already been calculated for us. So once you find the difference, you calculate the mean. So the mean will be summation of those differences divided by 8, then you get this one. Then you go on to calculate the standard deviation, which is the SD, then you get this one. So once you do that, you are able to calculate your SD over N, which is your standard error. So 7.6333 divided by square root of 8, you get 2.698, which is your standard error. So using this formula, you can see that this is our standard error, this one, which we have calculated already. The mean was already determined from the previous slide. Then you get your test statistics. The degrees of freedom is n minus 1, which is 8 minus 1 is equals to 7. So as you can see, for this example, it was not stated, so we use 5%. So we are testing at 5%. This is a one-tailed test. Because remember, we determined the one-tailed test was we are using less than, it means it's a one-tailed test. So we go to 5% to one-tailed test. Then you go to 7 degrees of freedom, so you get 1.85. So the decision is to reject, accept. Remember, okay, let's remember this is it's 1.895. 1.895, so it means 1.895. So what it means is we are saying less than, so minus 1.895. So minus 1.6 is less than, so it's somewhere here, which means we accept H0. Accept H0. Remember, always here, I don't know why I was leaving this. Accept H0 at alpha is close to 5%, because you must specify always. Accept H0 at 5% significance level and conclude that the new medication to combat insomnia does not result in any improvement. Practice questions on the t-test shall be covered in the exam prep section, so make sure to be able to do section 7 so that you guarantee that everything is done and everything is in place. So thank you for watching. If you have any questions concerning this section or you need any further information, call us on 074-920-9697. Thank you and you have a good day. Bye-bye.